I would like to invite our next speaker, Mr. Manish Sharma, Marketing Leader, GE Energy Management. He has over 14 years of experience in the field of industrial automation and has held various positions in GE. Prior to his current role, Manish headed the marketing division of GE Intelligent Platforms. Previously, he worked for Honeywell in various roles, ranging from product manager to global marketing leader. I would request Mr. Manish Kumar to come on the stage.
Thanks and good afternoon, ladies and gentlemen. Pleasure being here. And I'll start with my presentation on enhancing business performance using integrated visibility and big data. So big data is a word we have heard since morning. Everybody has their own views about it. We have our own views and pitch about it. Let's talk about it. First of all, an introduction on GE Energy Management. GE Energy Management consists of 4 P&Ls. It is industrial solution, power conversion, digital energy, and what's the fourth one? Digital energy, industrial solution, power conversion, and intelligent platforms. All right. From which I worked for 4 years, but okay. So what is our scope? We are basically a power company. We help in generation to transmission, distribution, and conversion. So the conversion part is taken care of by power conversion. Generation part, a lot of businesses are involved, including ours. Transmission, definitely a digital energy play. And protection also comes into that. We have different protection control relays, which comes out of our digital energy P&L. These are the range of products, motors and generators, power delivery systems, and so on and so forth. A lot of people know about them. A lot of people will know about them. So the main topic. So why are we here? We are deliberating about how to increase our operational efficiency. In an automation industry, we have seen the growth from microprocessors to all the way to DCS and the PLC. And the fight continues whether PLC is better or DCS is better. And for different applications, of course, and that fight, is a different issue altogether. From 2008 onwards, the world after Lehman Brothers collapse, and this was true earlier also, but now it is more prominent. We are faced with a scenario where we have to deliver more from less. The capex investment is reduced. You have to sweat your assets, which are multi-billion-dollar assets, over a period of time and deliver more efficiency. So how is that going to happen? A couple of things would be skill development. You need, better operators, better engineers to sweat those assets. Another thing would be a less of a downtime. Third would be, how to get different systems operate together so that you can have a better control over what you are buying, what is your inventory levels, how frequently do you need to train your operators. So GE looks at it this way. So multiple challenges, different systems, lack of integration. This came up in the Q&A also. We do integration every now and then. We integrate with Rockwell system, we integrate with Schneider system. In fact, Delhi Metro Operation and Control Center, we are integrating with all possible OEMs. And we run the show. Same with Rockwell. Rockwell is doing another OCC, which integrates other systems. So this can be done. There are challenges which are beyond the scope of this discussion. Second is poor access to historical data and plant-wide visibility. Arundhati madam talked about, how it would be great if we can monitor and control different assets across India. Now, this can be done. The technology-wise, this is not an issue. The issue comes when the systems themselves are not integrated. How do you control them? And even before you control them, do you see them in one HMI? Are you able to integrate the system? Do you make the business intelligence out of it? Another is process inputs keep on changing, so the PID loops never stay in the line. You have to keep on tuning them. Does the operator do it, or do the advanced process control software does it? If you don't use that, you have an issue. And then that leads to the quality rejects. The production batch never remains in the golden zone where you want to really produce the output, and so on and so forth. The prevention of equipment failure is something we'll go into more detail. So this leads to a loss of throughput, the higher the cost of goods sold. So basically, this is your input cost. And the fixed cost obviously goes up for a lot of reasons. Your systems are not connected, inventory levels are high, your operator which knows, or an engineer which knows a Rockwell system doesn't know how to program a GE system. So you need to have multiple redundancies in the system. And this leads to a lower operating margin. This operating margin is the focus nowadays in all the industries, whether it is the OEM or the end users. GE's answer is get connected. So this is something we have been talking about for so many years, and we never get tired of talking about it. And this is a slide which has run its course for the last two or 3 years. And it still holds so much relevance because we feel very passionately about it. So what do you mean by get connected? So in today's world, it's never going to be that an end user is going to buy one particular OEM. It will always be because of the buying behavior or the procurement policies or the cycle, except for a couple of oil and gas majors in private sector whose name I don't want to take. It's very difficult to standardize your whole operations on one particular system. So the whole idea is, from a technology point of view, if you can get your automation systems connected, you can derive the value. You can eliminate the problem of disparate systems with the lack of integration and the poor access to the historical data, because that's the next step. This leads to integrated visibility. Second leads to advanced analytics and preventive diagnostics. And third is the value chain integration. Value chain integration is something we are not going to talk about today. And once you get it all done, everything is green. So what's the solution? Step by step. First of all, you have to get your data into place. When I say get your data into place, it has to be properly historized, the data format has to be good, it has to be stored in a format which can be easily accessible. See, you have very cheap hard drives. Today is the world where you can buy a computer for 25,000 rupees. But that's what you want. You can have a shelf of computers, you can have a shelf of historical data, and if you can't access it fast, it's junk. It's paperweight. And actually, you will end up spending more money managing that asset. So a good historian with a high compression ratio and fast search and seek facility is something which is needed. Integrated visibility comes through portals and SCADA. SCADA is something probably which is from the day one in the automation industry, since the Windows-based technology came, and even I remember Honeywell TDC 3000, they had the HMIs which were touch screen later on, but it was pretty old-fashioned, but they were there. Analytics and decision support. This is where I remember, again, talking about Arundhati ma'am, 2 years back, Hyderabad, same conference. So she was talking about whether I can use my historical data to really troubleshoot what went wrong, what exactly was the problem, and how not to repeat it. So there are tools, and I'm very sure other OEMs also has that. If the historical data is good and it is fast and you can easily seek and search through it, you can actually set your process start time and end time, and you can run through it like a replay. And you can know which operator changed what value, which led to a trip of a particular motor, and so on and so forth. So these are the functionalities which builds on top of a good hygienic data. That's very important. The rest of the conversation is actually nothing. If your data is good, if you can really access it, if it is visible to you, if you can really search through it, that's half of the story done. And then integration with the business system. When we integrate into ERP, we know what is the safety stock, whether we can order things or not, and what is the production KPIs met or not. So this is what it is. So what does it do? So it's a fancy word for basically displaying data. That's what it is. And if you throw in mobility, then you have an iPad. And it all starts with a process giving you a parameter and a value and a data type over a protocol, whether it is OPC or whether you do it through Modbus or Ethernet. It goes and sits into SCADA. And then from that SCADA, you make fancy dashboards. But is it really as simple as I put it? So information is always about how you put it, how you make sense out of it, and what you do with it. It's a decision system. So that is where the human angle comes into picture. And with that analysis, with that data and the visibility that is possible, you can make out what are the variations in my cost of goods sold and what should be my optimum cost of goods sold and how to further bring it down. And this can be done either through, the portals or displays like this, or, well, this is not really a good example of the display. We have much more fancier displays. The point being, imagine a dashboard where you are monitoring an energy consumption of multiple HVAC compressors all across your assets. The make is same, the conditions are same, the square foot area is same. Then you basically say, why is my particular compressor consuming so much energy compared to another compressor? And this is what Delhi Metro Railway Corporation is actually doing now at a plant-wide level, at their own asset level. They are implementing the energy management solution. And it all starts with, getting the data ready, getting the data visible, putting it on an iPad or on a smart device or on a PC, remotely connecting it from anywhere in the world. That is most important. It cannot be just your HQ in Noida or HQ in Delhi. The facility for it should be mobile. So imagine a plant manager in some place in Jharkhand knows that the executive management in Noida can see the plant data. And that facility is very powerful. It drives human behavior. Otherwise, there is always an information asymmetry in the weekly reports that you get. It's not about threatening somebody. It's about, everybody knows everything. That being said about visibility, I have multiple examples of how we have implemented it. Without taking names, it has been the most focused industry adopting this technology has been the power sector. Next to power, and in power, when I say power, I mean wind, solar, and thermal. The next is the metal and mining industry, and of course the oil and gas industry, because oil and gas industry has a lot of money, so they invest in their O&M budgets. But this is just an example of how the architecture looks like. So you have a central control room, which has a SCADA and the dashboards that I was talking about, and in the back end, obviously the PLC will connect the data from the instruments and it will be dumped onto the historian, and the historian will be used to store the data. Historian is not necessary for a real-time data display, but it is necessary for accessing that data. Let's say, the last month energy consumption was so much, and why is it high this month? This is where you'll find most of the GE guys spending time on. All over India, all over the world. Our chairman, Jeff Immelt, keeps talking about it. He's very passionate about it. A lot of people think, okay, here is another GE guy who will talk about predictive analytics, where the whole world is debating, whether it is for real or not. Is it not real? We think it is pretty much real. And I'll come to a discussion why. I got a mail today morning, and this is just to set the context, that the British Petroleum has close to 4,000 oil fields all across the world. And they have decided to go on GE Predict's platform. So what does GE Predicts do? So without getting into too much of branding about GE, I'm saying that British Petroleum decided that they have to dump their 10 years of in-house effort of going into big data monitoring and analysis and going to somebody else, because they want to take a jump start into where things are in the market, and they want to build applications on top of it. So GE has put across a different organization called GE Software now, where all the GE businesses like energy management, GE Oil and Gas, GMCS, all the softwares will combine together, and they will be spearheading the promotion of the software technology and the R&D as well. So British Petroleum has decided to put Predict's platform on top of the 4,000 wells to predict not only the equipment failure, but the throughput of those wells over the next XYZ years. This is not just a simple case of BP doing it. I was in Florida last year, and my view, being in GE, I didn't have a complete view of what GE Predicts is doing and what GE Smart Signal is all about. I saw a lot of water utilities using Predicts or using Smart Signal in a beautiful way. They have come across, how to prepare their data, somebody was talking about when to manufacture water. That kind of decision making you can do through that. And I'm very sure there are other systems to do as well, but this is what we are doing. So this is a slide which talks about people, data, and machines. So these three entities coexist. And in the context of how they interoperate, you get the business results. Always keep it in mind that this is all about driving the operating margins higher and higher. This is all about not thinking like a factor economy, which we always think about. We still argue whether the platform screen doors on a railway station should be there or not, while others are talking about replacing them. This is about all these three things being, there, whether you like it or not. The data that is coming to you is massive. There is no way you can ask your operators to make sense about it. It is a computer's job nowadays. You cannot make sense out of it. If you really do it right, you cannot. And that's where the data analytics comes into picture and all the modeling and all the proprietary stuff that comes into picture. Well, that's a goal, 0 unplanned downtime. We have achieved in most of the cases, but machines being machines, or the limitations of the analytics that anybody can run, will always lead to some unplanned downtime. But the goal is to reduce it or eliminate it. So is this a concept for us? I've heard a lot of people over LinkedIn or even in the forums that I go, whether industrial internet is real, is it so much of hype? Now today we talked about Internet of Things, how Government of India is investing in it, how it's going to be a focus. For GE, this has been very much real for a lot of time. A lot of it comes from the aircraft engines that we provide. So you can argue this is in GE's control, so what's the big deal? Is this an endorsement of the end customer or an end user? Well, it is. That becomes our competitive advantage to sell. Gas and steam turbines, wind turbines, customer is under no obligation to put smart signals or data analytics on top of it. Medical equipments, definitely. Locomotives, yes. Plus, there are a lot of other equipments. We keep getting mails every day as to how a particular filter was choked or how a washer was going bad, and the software predicted. I'm very sure if you have a third-party software, even they can do the job. The idea is to adopt it. So, somebody who is not into predictive analytics, what happens? They don't see this coming. They don't see this coming, and then they wake up in the night with a burnt motor. And the lead time of the motor is 3 months or 6 months. Can we afford that thing to happen in a plant where you have invested billions of dollars and that asset is lying waste? The point I'm trying to drive home is this is no more a concept which you can, which is an optional thing. Yes, you will spend a lot of money. I'll not wait for the machine to go bad. I will do more of maintenance. There is a cost involved in it. Of course, you can reduce a unplanned downtime by doing too much of maintenance, but there is a cost involved with it. Is this the right thing to do? Let's sweat the asset, let's run it more, let's have more output. A lot of people are doing it in the world. So coming back to the story, if you can predict when the machine is going to fail, you can take a planned shutdown. And people who are the end users know about it. What's the difference between a planned shutdown and an unplanned shutdown? Planned shutdown is where people ask, when are you going up on load? And an unplanned shutdown is more about why did we have a shutdown? And nobody talks about when we are going up. Of course, that's the underlying theme. What does prophecy do? Or you can replace prophecy with anything, but what does the concept of a predictive diagnostic do? It compares the benchmark with the current performance. In my language, and I have a unique way of thinking about it. When people say Internet of Things, what does that mean? To my mind, Google comes into picture. When you search on the Google, it gives you various search results based upon what is the ranking of the page. You have hundreds and thousands of assets of the same make and manufacturer running in the background. If there was a way that I can input my data in a so-called Google industrial toolbar, and I get an output as to where is my percentile performance, What am I doing right? What am I doing wrong? Am I supposed to fail in the next 15 days, or even I can run for next 2 years? So that kind of benchmark performance, you can measure against the benchmark. Identify the gaps, obviously, that's basic. What is the cause of benchmark? Interpret. Where am I going wrong? What is my deviation? And what's more important is the analysis of it. If I'm not behaving as I should be behaving, or as 10,000 of my other peers are behaving, is there an underlying cause? Maybe there is nothing wrong with the pump. There is everything wrong with the input filter. The inlet filter of a boiler fuel oil pump may be getting choked. And everybody thinks that it's a pump overhaul that you need, and you keep opening pump over and over again, and it doesn't solve the problem. And so on and so forth. And these are all the boxes that we talked about earlier. It's all about increasing the contribution margin, increasing the operating margin, reducing the cost of goods sold. General slide about, everything is fine. You have your trends and data analysis, a visual representation even in DCS systems. Every DCS has it. I know about Honeywell because I worked there. At some point of time, you miss out the early warning, and manually you try to interpret it, and the warning actually comes and goes, and you forget about it. The shift changes, the another operator comes. Who has time to go through a last month's of data as to when is this pump's bearing temperature crossed a high temperature or a high temperature alarm limit? Nobody has it, trust me. That's when you need a software. That brings us to a point as to a software is the only entity which can crunch through, I don't even know what's the term for it, more than the gigabytes of data that comes every day. Early stage of detection, this is where you can plan your shutdown. So how does it work? From your data. When I say data, I mean the instrument pumping data on a PLC or a SCADA or a DCS controller. Going into SCADA, sitting into historian with proper timestamp and the device ID and whatever attributes that need to be. And that is when you pick that data and where you think is the correlation between that data. For example, if you take, let's say, a bearing temperature of a compressor, what is the input data that you need? The lube oil viscosity, the lube oil temperature, the bearing temperature, the load on the compressor, so many data. It's a wide matrix of what can cause the bearing temperature to go high and to make it bad. You take that data, you model it in the engine, and based on what is the data that you have given, and you keep on improving it. It's never a one-time job. You keep on adding more parameters as you go along, and a lot of domain knowledge gets involved here. And this is when the analytics basically come up with a trend. And the trend can actually predict as to you have around 5 months to 6 months to 1 year. And this is not a story. This happens day in and day out. This happens in a monitoring center in US where thousands and thousands of devices are monitored by engineers, of course, run by software, monitored by engineers when they deviate from the process. A customer can have their own monitoring center. A lot of customers have asked, what about the data security? Why should I give my data? There is a lot of concern about, it's my data. Why do you need to know? Well, we don't need to know. It's about, what are we going to do with it? And data is secure, by the way, but that's a different discussion. So every journey goes through, every adoption of predictive diagnostics goes through this phase. A lot of people are in the monitoring stage, and they are not really very good at it. Monitoring involves a lot of, data sanitization, data interpretation, and data collection. That's when you go to the diagnose phase, understand causes. That's where our troubleshooter and cause plus software comes into picture, where we run the diagnosis over the data that comes and say why a particular thing failed. But that is after the failure has happened. The discussion here is how to prevent the failure. Now you have reached a maturity level where you can do that. You go to the predicting problem. That's where corresponding G product would be a G smart signal. That's where you apply that or any other third-party predictive. I'm trying to be very conscious of the fact that I don't promote our products. So we're talking about the technology here, but I can't help it. Then you optimize your operations. That's when your advanced process control comes into picture, something like a C-Sense. And then you learn. And by learning, there are a lot of ways, and it flows into the integration with the value chain as well. Nobody can do it at one go. Nobody should try to do it at one go. There is a lot of human element involved in getting operators on board, getting engineers to buy in, getting your management to buy in. There is a lot of investment that goes. There is a desire or there is a pressure to have a quick ROI. But if there is a machine, if you are one of those lucky ones and there is no machine that's going to fail, you will actually think my investment has gone waste. This thing doesn't tell me anything. It would be better if a machine is failing and you are adopting it, then we are happy. But some examples, and there are multiple of them. The last one is the most important. It was, without naming the airline, it was reported on one of the airlines on a running engine. And when the plane landed, the engine was taken out for maintenance. And had the engine flown once more, it would definitely have resulted in either an emergency landing or a crash. And you cannot put a number to the value that came out of it. And these are typical examples of how a compressor in oil and gas facility, going bad, or there is a surging that is identified, and so on and so forth. A lot of applications are in oil and gas and power industry. Besides, okay, maybe I haven't come there. Besides to a lot of discussion about predictor, is it really real? Well, for us it is. We have been through a fantastic journey of questioning it ourselves as to the GE has got a new musical instrument and we play it all over. After all, isn't DCS something like 20-year-old? Isn't DCS something which connects within multiple systems of a plant? Isn't DCS something where you can put an application manager or an advanced process controller and can do the same thing? Well, no. You can't predict failures. And that's when the discussion, starts. So a lot of power companies are either showing interest, and I cannot take names, but one of the company has actually installed a remote monitoring and diagnostic system in their fleet, in the whole thing. There is another wind power, I wouldn't say operator, I would say operator who owns the assets across India. So they have the remote monitoring and a control system, and they run smart signals. There are solar power plant vendors who do that, renewables. So this is an example, wind, solar, hydro. Architecture is same, so we need not go through that. So in a nutshell, coming to the end of it, machines churning out data, and then if you leave the big data analytics piece out of it, and you can do that, and it comes to my graph about being on a stage 1 or 2, you can see the data remotely, visualize the data, and that leads to the physical and human network of intervention, and you run a plant as you do today. You insert a big data analytics piece here, and life becomes a lot simpler. The machine keeps moving. So this is the whole value chain. This is the center I was talking about. So multiple assets. We issue around 3,000 customer advisories. There is a very good hit rate. There are not false positives that come out of it. There are 200 catches every month, 500, and this data is old. This is like 1-year-old data. I'm very sure the count is more now. So instead of Morpheus, Agent Smith here. So blue pill or red pill, you have to take a pill. The industry has evolved in a direction where you cannot afford to sit back. And this is for end users. I personally, on a personal level, I find that the industry adoption is not that bad, especially in the private sector. Maybe it's the buying behavior of the PSUs, which how do you fit a procurement of something which is not a tender-based L1 and T1-based kind of a thing? You need 3 or 4 vendors to quote, and the whole thing goes on and on. Maybe operation and maintenance budget could be one thing, but if you look at India over the last 60 years, PSUs has been the driving force in the generation of industrial world in India. And they share the major bulk, and it's my request to PSUs to keep adopting more technologies instead of, I personally feel that, and it's my personal belief, that OEMs talk more about what is there. Everything just turns out to be a sales pitch at the end of the day, which is not a good thing. It's more about engineers talking about what can be done. We try to do justice as marketing and sales and business folks, but it's more about that input coming from the end user, and forums like ARC would be deriving more information about what the end users want. And every time I've heard end user, listen, they do talk about it, but more and more adoption and more on how to get it real would be a great thing, because it is happening all over the world. A lot of innovation-based economies are doing it, and the only way to transition from a factor-based to innovation-based economy would be to adopt new technologies, whether it is preventive diagnostics or whether it is something else, whether it is in consumer industries. With that, thank you very much for your patience, and good to be here again.